just sit back and listen, okay? All right, so just as like a recap, we've been talking about slopes, which come from functions. And functions are input and outputs that can be graphed on a coordinate plane, right? And what we've noticed, or what we're trying to learn, is that when I make a function and it turns out to be a perfectly straight line, that's what's called a linear function. And all linear functions have a rate of change or slope. So I just want to remind us of what that looks like. That's what we just did in our Kahoot, but we'll just do a quick reminder. So for example, hold on, let me make my graph really quick. Okay, so for example, if I were looking at this linear function, oh dear, what a terrible line. What we might notice is a pattern in this linear function. As I go from one line to one dot to the next one, it goes over 2 spaces and up 1, over 2 spaces, up 1, over 2 spaces, up 1. So that's what we call our rate of change or our slope. Okay, so that's just a quick reminder. So now let's talk about some new stuff. So we can also look at functions using an input-output table. So I could look at what is the input compared to the output, and let's see how the rate of change shows up in this table. So when I was at 2, it went to 1. When I was at 4, it went up to 2. When I went over to 6, it went up to 3. And when I went up or over 8, it went to 4. So if we recall, our rate of change was 1 over 2. How does that show up in our table over here? How does 1 over 2 show up in our table?
Because 1 over 2 is 1/2 and the y is half of x.
Oh, interesting. So our y is in fact half of x. So we see our rate of change happening in this direction. Does anybody need Anna to clarify that better?
Yes, please.
Okay, Anna, could you say it again, maybe in a different way?
So the rule of the input, that is x, and the output is that the input is divided by half and then it equals the output. For example, 2 is the input and divided by half it's 1. 4 and 2 and so on.
Yeah, absolutely.
You wanna?
Okay, perfect. Does anyone else see the input happening in another, or the rate of change happening in another way?
Miss, I have a question.
Yes.
That why do we, like in the, not in the graph, like in the other in the part, like why do we write like x first and y if y goes first?
Good question. So this is the table I've created. So the table I created is an input output table. So I want to show what goes in first and then show what comes out. Okay. Rate of change, though, is the relationship between our output and our input. So the rate of change is the reverse. It has to do with, I actually don't know why the y has to go on top. I think I was supposed to look that up for you guys. Why does let me think, hold on, let me search my math brain. Why does the y have to go on
Miss, I have a question that might relate to this.
top? Oh yeah, let's hear it.
That
Valentina.
like when you're doing like a word problem with money, it's
Yeah.
money or like time, the y or the x?
Ooh, good question. Time is almost always the input. Do you remember in 6th grade we learned about independent and dependent variables?
Yes.
Time is something that's independent. It goes on its own, whereas money is something that depends on the time that passes. That's not always true, but it's pretty much always true.
Ah, okay. It's because I thought that if it was the other way around, you could say that like depending on the y, the x that would equal, but no, it's not.
Yeah, but it's not that way. So Daniela, I feel embarrassed that I don't actually have a solid answer for you, that why the y has to go on top, but I do want to look into that and I will follow up with you. Okay, I promise.
Okay, thank you.
Okay, but I do know that in our tables, you know, this is our input and then it creates our output, so we want to show that. Maybe there's another way to look at this, right? So one way that our rate of change shows up is, like Anna said, it shows how to go from the x to the y. Okay, what if we also look at it this way? So I want to look at another pattern. In our graph, what we're looking at is how much does it change from one y to the next one? Let's do that here as well. How much is it changing from here to here, from here to here?
1.
These are each changing by 1, right? And then these, our x's, are changing by how much?
2.
By 2. So the rate of change in a table is also shown by how much the y's are changing. So our y's are changing by 1 and our x's are changing by 2. Okay. So in today's practice, we have a few different ways to find the rate of change. We can look at the pattern to go from here to there, right? Or we can also look at what's the change in the y. So looking at this and this and this compared to the change in the x. This is what we're going to focus on today and next class. Okay. Here, this was an example. I'm going to show one more and then we're going to try to do a couple problems together or on our own, trying to find the rate of change. Can I remove this screen or do we still need it here?
Remove.
Okay, anybody still need it? Going once, going twice. Okay, so just a quick, let's just look at one other example. We don't need to write this down. We can just observe it. So rate of change also works with the problem we were seeing for graphing, right? So we had this problem that we had the fastest train in the world. We graphed this problem last class, and then we looked at the rate of change from the graph. We might also solve this problem using a table. So if I make a table of this situation, I could then observe the rate of change in this table. Right, so I could look at how much are the hours changing and compare it to how much are the miles changing, and that will give us our rate of change. Okay, a couple questions. Do you think the rate of change in a table will always be positive?
No.
No, right? So there could be times, the examples we've seen, they always go plus, 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 plus. What would make it a negative rate of change?
To subtract.
Yeah, if I go minus, 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 okay. And then also, like we've already said, it does matter that the y goes first and then the x. Okay, so let's try a couple examples. let's say you have to do the first and last one, and you can do all three. You must do this one and this one, but you can also do this one. And let's start by writing them in our notebook, and then we'll talk about how we solve them. And while you do that, I'm going to look up why the Y has to go on top. Hmm. All right, just trying to give you enough time. Do we need more time with the first one? Do we need more time with the first one? All right. Does anyone that has not had the chance to speak up want to take their crack at using math language to, like, does anyone want to practice speaking out loud to explain the first one? It's good practice. You learn more when you explain
Wait,
it
me.
to others. Yeah,
I was doing like the third one.
okay, that's fine.
Like I got confused.
Okay. Well, before we get to the third one, because it has some extra steps, I do want to
No,
make
like-
sure we understand these two. Yeah.
I already did the third one, but like I didn't know we had to do the other ones.
Oh, that's okay. Did anyone do the first?
No, I only did the third one.
Okay, no worries. Did anyone do the first
Or
one?
we're gonna do it if it's already done.
Well, it's already filled in, but remember the ultimate goal is to find the rate of change.
Okay.
Hey, Gabe. Hey, Dario. I noticed you guys joined us.
Is number 1 times -2?
1 times -2. So, yep, tell me more. So the rate of change is -2. Did I hear you correctly?
I said times -2.
Okay, so let's talk through, let's make sure we can check to make that sure that's true. So practice using your math language. How did you figure that out?
Maybe I'm wrong.
It's okay if you're wrong though. Let's just talk about how you figured it out, and then let's judge from there. Like, no one is here to judge you. We're all just here to learn together.
That 9 times 2
Mhm.
is 18.
Yep.
And then 6 times 2 is 12.
Yep,
And then 3 times 6 is
absolutely. So you are totally correct. Do you see how my arrows though are coming from the output to the input.
Yes.
So we want to flip it around. That's all.
Ah.
So what would be the opposite? Instead of multiplying by -2, we would do
Divided by 2.
divide by 2. Okay, so our relationship is to divide by 2, right? It's kind of hard to figure out how do I write divide by 2 as a rate of change though. Anybody have any ideas?
How?
So if I'm dividing by 2 from here to here, is there a way we could express that? Like, remember, our rate of change is usually a fraction, or it's a number that's a simplified fraction.
I don't know, Miss, like -2/1.
Ah, you're so close. You're so close. So this would be the change. Okay, so let me say this way. So let's double check this in another way. What if we also look at this? You guys are really close. What if I look at it going this way instead? So what's happening from here to here?
-2/3.
Okay, let's see if that works out. So what's happening from here to here?
Wait, no, it's 3 -2.
Okay. Or 3 -2.
Wait, what?
I'm gonna just write down all of our options. Okay, so I'll voice what I would say. If I were to solve this problem, I agree with Eva. I would notice that from my input to my output, I'm dividing by 2, but I'm not sure this shows divide by 2. So what I would do if I were solving this problem is I would look at what's the change in the x's compared to the change in the y's. So here I'm adding 6 every time. Adding 6, adding 6, adding 6. Over here, what's happening? I'm subtracting 3. Okay, I'm just looking at what's happening from this number to this one. Okay, now I'm going to write that as a relationship between the y and the x. So the y comes first. The change in y is 3. The change in the x is 6, which is the same as what?
1
Over
2.
2.
Miss, so that's how we could solve like every problem. We just need to.
Yeah. Yep. And then now we see that this is related to Eva's relationship because dividing by 2 is the same as multiplying by 1/2, right? But I encourage you that instead of starting here, I encourage you to start here with the green options, right? Think about how's the change happening from one to the other before you think about this direction. Okay, so does somebody want to take a crack at explaining the second one before we finish our third one? No pressure. If you want me to explain it, I can, but I just want to give anyone the option to practice saying it out loud.
Is it 7?
Yeah, and can you tell us how you figured it out?
That 1 times 7 is 7, 2 times 7 is 14, and so on.
Yep, totally. Okay, and then how else does the rate of change show up?
And 7 plus 7
There you go.
equals 14, and then plus 7 is 21. And 1 plus 1 is 2, and 2 plus 1 is 3.
Yeah.
2 plus 1 is 4.
Good job. So the change in this 7 is, or the change in the y is by 7s, and the change in the x is by 1s. Okay, so we're starting to realize that there's many ways to find rate of change in a table. And there's also many ways to check if you have the correct answer. So that leaves us to this problem. There's a ton of different ways to solve this problem, right? The first thing we have to do is kind of fill in the missing blanks. And again, there's many different ways. So does someone want to throw out one way they found a missing blank?
If you look at the one at the very bottom that has both sides,
Uh-huh.
you can see that, like, I know that 9 times 3 equals 27, so I just add a 0.
Okay.
So 30, like, from x to y, it's times 30.
Yep, that is true. Okay, so one way is to look at from x to y is times 30.
Uh-huh.
That's absolutely true. How would we figure out this one then?
I also
Oh, go ahead.
I don't know if I'm right, but like I did like 4, but no, I don't know what I did wrong,
No, I like that though. Where do you see the 4 happening?
because like the x, like it
Uh-huh.
was like -4.
Exactly. Okay. And then let's do that again. Let's -4 again. What would I get here?
1.
And then if I -4 again, do I get -3?
Yes.
Yeah. Okay. So another way to look at this problem is to look at this pattern, right? Now, here's where it gets a little funky. This side is going -4, and that's every one box. This side, they skipped a box. So how can we use that to figure out this one? Do you know what I mean? Like, how can I use the box that I skipped to figure out this box here? Let's do that. So what's the difference between 270 and 30? Right, that difference would be 240. I kind of feel like maybe half of you aren't listening anymore. Okay, so that would be 240. So what would be the difference here? If this 2 boxes is 240, what's the amount of 1 box?
30.
Careful, try again, because that'd be this relationship. So if 2 boxes is 240, what would be half of that?
120.
Uh-huh. I'll explain the 30 in 1 second, Daniela. So from here to here, we go down by 120. Why isn't it 30? Why isn't it going down by 30s? Does anyone think they could explain that?
Oh no, like I know why it's not going down by 30s, but like I don't know why I did 30 then.
Because here's why you did 30. Because this relationship is a 1 by 30. So if this were going by ones, let's say it went +1, +1, +1, +1, then this would be +30, +30, +30, +30. But
Oh.
on our left hand side, it's not going by ones, it's going by 4s. So if we notice, 4 to 120 is the same as 1 to 30. So there's tons of different ways to see this problem, right? Like we could use this pattern, we can use this unit rate, and we can also use this relationship from here to here. But all of these things, everything in orange, pink, green, and blue, those are all rates of change. Everything we're talking about means the rate of change.
Oh, so means the rate of change would be 30 over 1.
Yeah, yeah, hooray. So the rate of change would be 30 over 1. Okay, you guys have done a lot of critical thinking. We have one more example that's going to be really important before we leave today, but I think we could use just a 5-minute brain break. So go ahead and take 5 minutes. And if you want to stay and ask questions about these 3, you can, but I would really recommend we just take 5 minutes and then we'll talk about the next few problems.
Miss, math is getting so hard now.
No, don't say that. No, no, no. Like we're just looking at we're just looking at how this changes from one to the next. We're just looking at patterns. We're just having fun. What is it just like the concept we're learning harder things? That is definitely true. I feel like fun things are kind of fun to, or hard things are kind of fun to talk about though. Like it's kind of boring if all we do is talk about easy things, don't you think? Oh, now Fede doesn't want to talk to me.
What?
I was just saying, I think it's fun to talk about like more complex ideas, harder things. It's kind of boring if all you talk about is easy things.
Yeah, that's true.
That's true. The other thing about today is I'm trying not to answer every question for you. Like I'm trying to make you also think through it. And sometimes that can feel harder than what it actually is. Like what we're actually learning is just real simple. You're just looking at the change from here to here to here, here to here to here, and you're writing it as a fraction. But I'm asking you questions that make it a little more complex, I suppose.
Means I have a question.
Yeah.
That like, isn't it supposed to be negative?
Which one? The negative 30?
Uh-huh.
Well, I know that all of my arrows are going up, but technically, once we fill in this box, once we fill in all of these, hold on, let me fill this one in.
Oh, you could do it like the other way.
Yeah, we want to look at in an increasing direction. Does it go positive or negative? So if we look at it going increasing, it still increases as we go.
Oh, okay.
You confuse me. It's minus 21, right? Because there's.
Oh, no, it's minus 210.
Ah. Okay, thank you.
Okay. All right. The next problem we don't need to write down. Just sit back and listen and try to answer the question or try to think of what someone else would answer. And then we'll write down the last few examples at the end. So this one, you can just sit back and relax. So we've got this idea. There's all these different ways to find the rate of change in a table. So what if we look at this one? Okay, so look at it for a moment. Okay, so the question is, how is this one similar, but also how is it different? So shout out, what are some things you notice? Maybe you already know the rate of change. What is the rate of change? And then let's talk about how is it similar? How is it different? So I'll take notes. You guys tell me what you notice.
That there's a point where the X, the input, and Y output like it's 1 and -7.
Okay.
It's like the other problem.
Uh-huh. Okay, so this one also told us a unit rate, which is nice and convenient because what do we know about the unit rate? It's also the oh, maybe not. Okay, we'll start there. What else do we know?
That from x to y, I think it's times -7.
Ooh, okay, so from here to here, I times by -7. So we have this relationship that I can times by -7. All right. So those things are similar, right? It has this unit rate, and it also shows us from the x to the y, we times by -7. Okay. Anything else we notice is similar?
That it goes
Or maybe different?
the x like from 9 to 5.
Uh-huh.
There's a difference of 4,
Okay.
like the other problem.
Okay. Keep building off of that idea. Someone build off of Eva's idea.
I don't know, Miss. I'm kind of like confused.
That's okay. We're just looking for patterns. So let's build off of Eva's idea. She said from 9 to -5, it goes +4. So remember, we're looking for rate of change. So what would be our next step in finding the rate of change? If I know this side's +4, what else do I have to know?
Find like the other side.
Oh, let's do that. What's this side? Is it going to be a plus or a minus?
-28.
Okay. -28. All right. What else? So
Miss, I have a question because it's not like consistent because 35 minus 28 is not 28.
so what's different, right? In this example, Anna's noticing, oh, from here to here, it's -7. From here to here, it's what? +1. Let's look at this one. What's this pattern?
So it wouldn't be a linear equation. Or...
That's the question of the day. Okay, so what we're noticing is it doesn't follow a pattern. So A, sorry. Okay, so it's not following a pattern, but does it still have a rate of change? So that's what we're wondering. Does everyone understand what we're saying in green here? Like this does not follow a pattern? Is everybody with me?
Yes.
Okay, I got 2 of you.
Yes.
Okay, so the question is, oh, go ahead.
No, I'm not understanding.
Okay, so what we see, like this table still has that when I go from 9 times -7, it gives me 63. 1 times -7, it still has that relationship. But do we see how it doesn't follow a pattern? In all of our other examples, all of these tables, they follow a perfect pattern, right? +12, +12, +12, -4, -4, -4, -4. It's always the same. In this table, it's not the same. So Daniela asked, is this a linear equation? The answer is yes. So even though those don't follow a pattern, if I compare them all to each other, so if I compare this change compared to this change compared to this change, it still is 7 to 1. So the rate of change in this table is negative 7 to 1, even though it's not following a perfect pattern. And the reason why is because all of the patterns it does have are equivalent to negative 7 over 1. So before we do example problems, I just want to relate this to our graph. If you recall, when we were making graphs, we saw some examples, like here's my graph, right? The change from here to here is maybe 1 over 2 or 2 to 1. And the change from here is 2 to 4. Are they still the same? Do they still have the same rate of change? Are they still describing the exact same relationship? Yeah.
Yeah.
Yeah. Okay. So our final task today would be to try some tables that don't follow a pattern, right? So if I were to solve this first one, and we're going to just pick 3 out of these 5 problems, just pick 3. In this first one, I look at this rate of change, and I also want to check it on another one. So as long as 2 or more of the rate of changes are the same, then I know that it's correct, right? So from here to here, it's 2 to 14 and 1 to 7. Well, those are the same. Therefore, I know the rate of change is 7. So it's like whatever is the most reduced form is our rate of change. Okay, so our final task today in the last 10 minutes would be to pick 3 of these problems. Obviously, we've already done this one, so you can't pick that one.
So we have to do 3 of them.
Yeah, let's do 3 of these. Find the rate of change in 3 of these tables. Okay, I'm gonna do something really quick. Okay, so I moved some of the girls out of this room. So it's now just the 4 of us. So the 4 of us, what would be the rate of change in this table here? Have you guys looked at this one? Or what's one that you've looked at?
Miss, I'm not understanding because like they don't have like a specific pattern.
Ah, okay, so let's check that out. So, okay, which one do you want to look at?
Can we look at the 5th one? The 5th one.
Number 5? Yeah. Okay, so it doesn't follow a pattern. So let's just look at what we've got. So from here to here, what's the change?
12.
Over here would be plus 12, and then over there would be plus 2. Let's go down to the next one. What's the change from here to here?
Plus 2.
Plus 2, and then over here,
What?
oh,
What?
also
Plus
plus 12.
12.
Okay.
Wait,
Oh, sorry, I'll wait.
in the X one, why is it 2? Ah, no, nothing.
Yeah, okay. How about this one though? What's the change from here to here?
1
Plus 1.
Plus 1. And what's the change from here to here?
plus 6.
Okay.
No.
Uh-huh.
Yes.
So
Yes.
we have two different, I'm using quotations, we have two different rate of changes. We have 12 over 2 and we have 6 over 1. Well, what do you know about those two numbers?
That they're like the half of each one. Like
Yeah. So which one would be our official rate of change? What's the most simplified form?
the 6 over 1.
So you could say the rate of change is 12 over 2, but that is the same as 6 over 1. So our rate of change is 6 over 1.
But where did you get the 12 over 2 and the
Yeah.
6?
So I got those by looking at how much does it change from this x to this x and this y to this y. Right, like I'm looking at from this value to this one, it changed by 2. From this one to this one, it changed by 12.
Okay.
Did that help, Arturo?
Yes. Thank you.
Okay. How about Dario? How you doing? Oops, sorry. Dario, do you think if I asked you to explain a problem, you could?
I think, but I'm still a little confused.
Okay, I'll help you out. Let's do the sixth one. So for the sixth one here, we need to look at the rate of change. So what's the change from here to here?
Plus 6.
Yeah. And what's the change on this side from here to here? Check your microphone, Dario. I don't know if you. Oh, Dario, you're having your microphone problem again.
Wait, does it work now?
Yes, there we go.
Yeah, sometimes it doesn't work.
That's okay. Let's leave it on for this problem so that it doesn't go away.
Okay.
So what's the change on this side? What's the change in the y?
That's
You'd use your fingers like 19, 18, 17, 16, 15, 14, 13, 12. Oh, I think I lost you again, Dario. You could maybe use the annotate function, like you could go onto your,
does it? Okay, I think it works.
okay, so this would be how much is changing from 19 to 7?
11.
Close. Don't count, or make sure you count after the 19. So 18, 17, 16, 15, 14, 13, 12, 11, 10. I get 12, but yeah, same difference. And then here again, this would be plus 6. And from here to here would be plus. help. I think I lost you again, Dario.
I can answer. I think I can answer it.
Okay, b plus 12. So what would be our rate of change for this table?
That would. So wait. Is 12. Is 12. 12 over 6.
Mm-hmm. Exactly. Which is, and that's the same as 2, or like 2 over 1.
Ah, wait, what? And then can we simplify it?
Yeah, you always want to simplify.
Okay, so the rate of change is 2 over.
2 over 1. Yep. Okay. Gentlemen, if you still want practice or if you still need more help with this, there is a Khan Academy topic. So you could do these Khan Academy problems. Or there's also a video on slide 5, and you can find these slideshow on Google Classroom. I'm gonna let you go for the day, but if you do want more help, you could watch this video or do this Khan Academy. Okie dokie.
Miss, for the problem for in those, like the one we did before,
Yeah.
what was the final answer? Like to check what I got.
In problem 4,
Yes, on that
yeah, it's a -7 over
one.
1.
Yes. Okay. Thank you.
Okay. All right.
Can I leave the Zoom?
Yes, you may. I will see you next class.
Bye.
Okay.
You.
Bye-bye.